All right, hey guys, this is actually my second time to do this, but you know, the second class is always better. Um, no offense to my first class. No, I'm better because I've said it before. Anyway, the whole point of that was I have been trying for a bit to get this to work correctly. So, we're gonna do lesson 90. It's going to be great. So lesson 90 is word problems with two statements of equality. We've been doing these. We've been doing them in the form of coin problems and in the form of general value problems. We just did those where we get our two statements with equal quantities, and then we use substitution or elimination to solve for the missing variables, right? So we're going to do the same thing today. We're going to use word problems. We're going to have more than one variable, and we're going to use substitution and elimination to solve for what they're asking, okay? So let's just take a look at the first one, example 90.1. Together, Charles and Nellie picked 92 quarts of berries. If Charles picked 6 more quarts than Nellie picked, how many quarts did each of them pick? Peter Piper picked a peck of peppers. How many was it? So what do we know? What do they give us? What information do we have? We know that together, that means Charles plus Nancy picked a total of 92. So the number of Charles's plus the number of Nancy's equals 92. Okay? They also said if Charles picked 6 more quarts than Nellie picked, how many quarts are they? So Charles picked 6 more than Nellie. So the number that Charles picked equals or is 6 more than Nellie's. So more tells us to add. So we have the number of Nellie's, and if we add 6 to that, we'll get the total number of Charles buckets, quarts. I don't know, whatever it's on for. So we can't just use the number of Charles plus the number of Nancy's to solve because they're not equal. So and then we need to know what the number of Nancy and the number of Charles are. So that's the second equation. But now we're back to what we're familiar with, right? We just substitute. We're going to take the number of Charles and we're going to put that back into our original equation. So we have the number of Nancy, because I'm using this portion, right? Plus 6, and then back up to this equation, then plus the number of Nancy would equal 92. So I have 2 number of Nancy's, and I'm going to subtract 6 and subtract 6. And that's going to give me 86. So the number of Nancy's after I divide both sides by 2 equals 43, right? So now that I know that Nancy has 43, I can easily solve for the number of Charles's because I can go right back up here, right? And the number of Charles equals 43 plus 6. So the number of Charles must equal 49, right? So now we know how many quarts each of them picked. And 49, just to double check, plus 43 equals 92. And where did I get that from? That's here. This is my double check. Double check. We got it right. I know y'all love to double check your work. But it really is, you can do that part in your head. I write it out, but if you'll go back and put it in the other equation, and why not? You can double check your answers. Yes, please. 90.3. Philip cut a 38-meter rope into 2 pieces. The long piece was 9 meters longer than the short piece. What were the 2 lengths? So we have 2 lengths. We have a long one, and we have a short one. The first part says he cut those into 2 pieces. So if we added those together, we would get the total length of rope, which is 38. Okay. Then it says the long piece was 9 meters longer than the short piece. So what does that tell us? The long piece is or was, same difference, the short piece plus 9, right? 9 meters longer. So you take that short, add 9 to it, and you get the longer one, right? So now that I have my 2 equations, I'm going to substitute my I'm going to just, because it's already solved that way, I'm going to substitute it like that. So S plus 9 plus S equals 38. So now I have two S's, and I'm going to subtract 9 from both sides, and I'm going to get 29. Is that right? Yeah. Divide those sides, and I'm going to end up with S equals 14, yeah, 0.5. Just double checking. So now that I know S, I can take my information up here, and I can say L equals 14.5 plus 9, and L must equal 23.5. So there's the long side, there's the short side. If I add those together, do I get 38? Yes. So we double checked our answer. You don't have to write it out. Just do it in your head or use a calculator, but go back and use this equation to double check yourself, right? Okay, let's look at 90.5. 90.5 says the greater of two numbers is 16. The greater of two numbers is 16 greater than the smaller. So we have two numbers, a greater and a smaller. The greater one, the greater number is, that's your equal sign, 16 greater than the smaller. So my smaller number plus 16 is going to equal that greater number. When added together, they're talking about the greater number and the smaller number. When you add those together, the greater number plus the smaller number, their sum is, that's our equal sign, 4 less, so we're going to be subtracting 4 less than 3 times the smaller. What are the numbers? So look at the equations we've set up and then go back and read it just to help you grasp how we got this, these two equations from the words they gave us, right? The greater of two numbers, so that's where we get the G from, is, that's our equal sign, 16 greater than the smaller. Well, S is our smaller, plus 16 makes it 16 greater. Then it says when added together, it's referring to the greater and the smaller number, okay? When added together, G plus S, their sum equals or is 4 less, so we subtracted 4, then 3 times the smaller. That's 3 times S, that's 3S. What are the numbers? All right, we just solve away. We already know what our greater number equals, so let's substitute this one here into here. So we get S plus 16, that's our G value, plus S equals 3S minus 4, right? So that gives us 2 S's on one side. Just write this one out. Plus 16 equals 3 S's on this side minus 4. So I'm going to put all my S's on the right of the equal sign because I want it to stay positive. So I'm going to subtract 2S here. Subtract 2S. I'm going to add 4. I'm going to add 4. And then that gives me 20 equals S. Well, that was easy. So we have 20 equals S. So we can plug our S value back up here, and our G greater number equals 20 plus 16, right? So G must equal 36. Now, if we plug G and S back into this equation, they should equal one another. You can double check that, right? Okay. Let's do 90.6. 90.6 says, gotta turn the page. The ratio of two numbers is 5 to 4. Oh, ratio. Wait, time out. What is a ratio? Okay. Ratios are fractions, remember? So if we have A, that's an A, it's terrible, A over B, we would read that as the ratio of A to B, right? A to B, the ratio of A to B. So it's just a fraction. so don't freak out. Come back. We can handle this. It says the ratio of two numbers. So I have a ratio of two numbers is 5 to 4. And the sum of the numbers, so I have a one number plus a two number, that's the sum, equals 63. There we go. We have our two equations. Now what? Yikes. Okay, so we have our ratio of the two numbers is 5 to 4, and the sum of these two numbers is 63. We're going to cross multiply. So we're going to multiply like that to get us a linear equation here. So we're going to end up with 4n1 equals 5n2. So I used elimination with this one. I went ahead and set this up as 4n1 minus 5n2 equals 0. And I'm going to line this up with my other equation that we already have set up. So 4n1 minus 5n2 equals 0, right? I'm going to multiply both, the bottom line times 5. So if we multiply anything times 5, we have to multiply everything times 5, right? So that gives me 9, and then we're going to add. So that gives me 9n1, and then these cancel out. Negative 5n, positive 5n, those cancel. Equals 63 times 5, which is 315. Okay? I'm going to divide both sides by 9, and my first number equals 35. Okay? Then I'm going to go back to my original n1 plus n2 equals 63. n1 plus n2 equals 63. So n2 equals 28. Okay, again, hardest part of this is setting up your equations, and then you just have to decide if you're going to use substitution or elimination, okay? But if you set up a ratio and you cross multiply, you're back to something that looks more familiar, and we can plug that into our substitution or elimination model, okay? All right, I'm about to cover practice problems, so pause it here if you want to work them first, which I highly recommend. Working practice problem A, and I'm going to work it out for you, okay? So the sum of two numbers is 98. The difference of the same two numbers is 40. What are the two numbers? That one's pretty easy. All right. The first number, the sum of two numbers. What does that mean? That means to add, right? Number 1 plus number 2 equals 98. Yes, please. The difference, what does that mean? Subtraction. The difference is of the two numbers equals 40. Well, if this isn't a prime elimination situation here, right? So I'm just going to add these together because that's going to cancel out that second number. That's going to give me 2 of the first number equals, these cancel, 98 plus 40, 138. All right, so then I divide by 2, and n1 equals 69. So I can plug that into either one of those, right? If 69 plus the second number equals 98, then the second number must equal 29. So it also should stand to reason that 69 minus 29 should equal 40, because that's our second equation. And it does. So we have our first number and our second number. solved. All right, if you hadn't worked B, work B. And then come back and see if we did it the same. Because again, you can do substitution or elimination, but you're going to come up with the same end values, okay? The number of girls in Marvin's class exceeded the number of boys by 11. So the number of girls were 11 more than the boys. So the number of boys plus 11. If there were 37 pupils in the class, how many girls and how many boys? So what do we know? The number of boys plus the number of girls. So the number of girls plus the number of boys equals 37. All right. Well, let's substitute. Let's take the number, I did it different. Let's check. The number of girls exceeded the number of boys by 11. The number of girls. All right. I wrote it backwards. So it should be that the number of boys equals, let's see that, yeah, equals the number of girls plus 11. Is that right? The number of girls in Marvin's class exceeded. So the number of girls should be bigger. I did it right the first time. I doubted myself. Okay, I'll be really honest. I did it wrong in my notes. So it must be the number of girls exceeded the number of boys by 11. The number of girls by 11. So this would be the boys. Okay, so let's substitute. We have the number of girls plus the number of girls plus 11. No, I did it right in my notes. I just doubted myself. Okay. Equals 37. So 2 number of girls equals 26. So the number of girls equals 13. And that makes the number of boys equal 13 plus 11. So the number of boys equals 24. All right. It's terrible handwriting. I'm writing on my computer. So that means that the number of girls plus the number of boys should equal 37. 37 definitely equals 37. And we have checked our problem. All right, let me know if y'all have any questions about lesson 90.